Welcome back to a new video lecture, and in this lecture we will discuss a very new topic called moment distribution method. Actually, it is also a method of displacement method for the analysis of indeterminate structure. And using this method we can analyze continuous beam frames. Okay. And here we will discuss some of the important terminologies required for studying this moment distribution method. Okay. So first one is carryover moment. So actually what do you mean by carryover moment? Actually the term also indicates carryover moment. So with the example I will explain. Here a beam is given and with one end is hinged and the other end is fixed. So if you are applying a moment with the magnitude m, it is transferred or carried over to the other end, that is a point B, with the magnitude m dash. Once again I will repeat. A moment with magnitude capital M is applied at the joint A, and this joint is hinged, and this moment is carried over to the joint B which is fixed. Okay, with the magnitude m dash. So there is a term called carryover factor, and it is represented as carryover moment by applied moment. Carryover moment in this case it is m dash, and applied moment it is capital M. Okay. Then coming to the stiffness. It is represented as, stiffness is represented by K, and it is known as, if you are applying a moment, that is m in this case, to produce a unit rotation, that is represented as theta A. Okay. So if you are applying a moment to produce a unit rotation, that is called stiffness. Okay. Then there is a term called distribution factor and distribution moment. Here we can check out. This is a there is a lot of connections over here, and it is represented as OA, then OB, then OC and OD. If you are applying a moment at the joint, this joint O, this moment can be shared to each joint, that is OA, OD and OC and OB. Okay. And if you are taking particular, the distribution factor for this particular OA, it can be represented as, if this MOA is the moment shared for this particular section or OA portion, then you can represent as MOA by applied moment capital M. Once again I will repeat. The distribution factor and distribution moment represents, if you are applying a moment over a joint and it is connected to various beams, then that moment will be shared, that is, if M is applied at the joint O, it will be shared to each joints, that means OA, OD, OC and OB. And distribution factor represented, if you are taking a particular beam, that is, if you are applying for this OA, then it can be represented as MOA by capital M. Okay, so this is the important terminologies regarding the moment distribution method. Okay, I hope the section is clear, and with this we will wind up today's section. Thank you.